All right, so we have now a box at an incline, and we want to find what should the coefficient of static friction be so the object does not accelerate, meaning either it doesn't move at all or it moves with a constant velocity. All right? So we want to find this, what kind of static friction can we have? Do we need to have? So we start by doing the free body diagram, make sure that the x-axis is parallel to the surface, the y-axis perpendicular. So what forces do we have? We definitely have the force due to gravity. We definitely have the normal force. You see, the normal force is always on the y-axis because it's perpendicular to the surface. Now, we have friction, right? We have friction. What's the direction of friction? Well, if the object were to move, it would go down, it would slide down. That means that friction that stops it should be upwards. So the static friction should be upwards. We don't apply any forces, there are no other forces. These are the three forces. So apparently the first thing we do is resolve the force due to gravity into the horizontal and the vertical components. Let's say that this is not a very nice axis. Let's have it, I don't know where to have it. Let's have it here. So let's say that these, so static friction will have this direction, normal force will have this direction, and the two components of force due to gravity, the x component and the y component, should be like that. So resolving means using the formulas, and we say, all right, so we do know that the force due to gravity is mg mass times g, so it is 50 newtons in our case. That means that the Fgx will be Fg sine theta. Sine, yes, sine. The x gets the sine because now the x-axis is not adjacent to the angle. The y component will get the cosine because the y-axis is adjacent to the angle. So Fgx will be 50 times the sine, so this would be half of 50, so this should be 25 newtons. Well, Fgy should be 50 times 0.866. That means that the Fgy should be so the 100 is 86, the half of 86 is 43.3 newtons, I think. So we do know these two forces. And now we're ready to use the sum of forces on the x and the sum of forces on the y-axis. So this problem is actually has to do with what we said so far. Because what happens now? So I know one force on the y-axis. I know one force on the x-axis. So how am I going to use them? Well, from the Fg, I will be able to find the other force on the y-axis. From the Fgx, I will be able to find the other force on the y-axis. From Fgx, I will find the other force on the x-axis, and from these two, I will be able to find the coefficient of friction. This is what I'm going to do. So let's say starting from the x-axis, I do know that the sum of forces on the x-axis should be 0. That means that static friction minus Fgx should be 0, which means that static friction should be equal to Fgx, so it should be 25 newtons. Now, so I found the static friction. Let's go to the y-axis. So the sum of forces on the y-axis is zero, just like here, which means that the normal force minus Fgy should be zero, meaning that the normal force should be equal to Fgy, so it should be 43.3 newtons. Now, I know the normal force, I know the static friction, all right? I know the normal force, I know the static friction, so I can find the coefficient of friction. So static friction equals the coefficient times the normal force, or else the coefficient is static over normal force, which is 25 over 43.3. And of course, just because they're both newtons, the coefficient of friction is just a number. It doesn't have any units. Now, this is a case with values. What happens if I want to find the general case? No values, right? I don't know the angle, it's just theta. It is just theta. All right, so I don't care for this, I don't care for this, I don't care for this. What do I care for? I care for the fact that the x component can be written as mg sine theta, while the y component will be mg cosine theta. In this case, the static friction will be exactly equal to Fgx, meaning that it will be mg sine theta. And the normal force, just because it's equal to Fgy, it is mg cosine theta. So if I go here, what do I find? I find that the coefficient of static friction is mg sine theta over mg cosine theta. Getting rid of the masses and the acceleration due to gravity, what do I find? I find that the coefficient of static friction equals the tangent of theta. And actually this is a way to find the coefficient of static friction. If you have a surface, if you have a surface and you put an object on top, you can find the coefficient of static friction between the two surfaces if you start changing the angle. And you find when you find the angle that the object will look as if it's ready to start sliding down, if you find the angle, right, at this point, the tangent of that angle will give you the coefficient of static friction. This is a lab that can happen.